I made the greatest mistake of my life when I told the world that time could slow down. Not because it was wrong, but because I knew what it would mean for human heart. You see, when I discovered that time passes differently for objects moving at high speeds, I created the cruelest thought experiment imaginable, the twin paradox. One brother stays on Earth, the other travels to the stars at nearly light speed. When the space traveler returns, he has aged only months, while his twin brother has aged decades, maybe even died of old age. The traveling twin returns to find his brother's grandchildren older than he is himself. Every night since that revelation I've wondered, did I give humanity a glimpse of the universe's deepest truth, or did I show them a prison they could never escape? Let me tell you why this isn't just a thought experiment anymore. It's happening right now. The smell of fresh ink on my equations still haunts me, because I remember the exact moment I realized what I'd done. It was 1905, a warm spring evening in my small apartment in Bern. I'd been working by candlelight, wrestling with the implications of my special relativity theory. The mathematics were elegant, beautiful even. Time dilation, length contraction, the speed of light as the universe's speed limit. But then, as I stared at those elegant equations, a horrifying scenario crystallized in my mind. Two identical twins, let's call them Hans and Fritz, after my childhood friends. Hans decides to stay on Earth, living a normal life. Fritz becomes an astronaut and travels to a nearby star at 99.5% the speed of light. The journey takes him 1 year there and 1 year back, as measured by his ship's clock. But when Fritz returns to Earth expecting to find his brother only 2 years older, he discovers that Hans has aged 20 years. My hands trembled as I wrote down the calculations that night. The time dilation factor at 99.5% light speed is about 10. For every day Fritz experiences on his ship, 10 days pass on Earth. For every month of his journey, Hans ages 10 months. Fritz's 2-year-round trip corresponds to 20 years of Earth time. I remember dropping my pen. The ink splattered across my papers like tears. I had just mathematically proven that the universe allows for a form of time travel that could tear families apart forever. But here's what kept me awake that entire night, and many nights afterward. The asymmetry wasn't immediately obvious. Both twins, during the constant velocity portions of the journey, would see each other's clocks running slow due to special relativity. Each would think the other was aging more slowly. This seemed like a contradiction. How could both twins be aging slower than each other? The resolution lies in a detail that would haunt me for decades. Acceleration. Fritz's journey isn't purely uniform motion. He must accelerate away from Earth, then decelerate when he reaches his destination, accelerate again to begin the return journey, and finally decelerate when approaching Earth. Hans, meanwhile, remains in the same reference frame throughout the entire journey, experiencing no significant acceleration. During those periods of acceleration, Fritz experiences something Hans never does: the effects of acceleration on space-time itself. According to general relativity, acceleration is equivalent to being in a gravitational field. When Fritz accelerates, he temporarily experiences the passage of time differently than if he were moving at constant velocity. But the mathematics reveal something even more disturbing. The overwhelming majority of the age difference doesn't occur during these brief acceleration phases. It accumulates gradually throughout the entire journey. During the long periods of constant velocity, when Fritz is either traveling toward or away from his destination, in Fritz's perspective during the constant velocity phases, Hans's clock appears to run slow, just as special relativity predicts. But here's the crucial point. When Fritz turns around to come home, he changes reference frames. During that change, he must account for what's called the relativity of simultaneity. Let me explain this in a way that makes the horror clear. While Fritz is traveling away from Earth, his definition of now is different from Hans's definition of now. When Fritz looks back at Earth through a telescope, he sees Hans's clock running slow. But when Fritz turns around to come home, His new definition of simultaneity suddenly jumps forward. In an instant, from Fritz's perspective, Hans's clock appears to leap ahead by many years. It's not that Hans suddenly ages rapidly, rather, Fritz suddenly realizes that many years have already passed on Earth while he was traveling outbound. The relativity of simultaneity means that Fritz's turnaround essentially causes him to catch up with Earth's timeline. I calculated this dozens of times, hoping to find an error. The mathematics were merciless in their consistency. The twin who travels always returns younger than the twin who stays home. Always. The human implications crushed me. Imagine Fritz returning to Earth, still young and hopeful, only to find Hans gray-haired and frail, perhaps even deceased. Fritz would attend the funerals of friends who were young when he left. He would meet their children, now adults with families of their own. He would walk through his hometown, recognizing nothing, understanding that everyone he ever loved has been swept away by the relentless current of time, while he remained frozen in amber. But the universe doesn't care about human hearts. The mathematics of space-time are indifferent to our emotional needs. Time dilation is as fundamental a property of reality as gravity or electromagnetic force. And this isn't merely theoretical anymore. We've measured time dilation with atomic clocks. We've seen it in particle accelerators, where high-speed particles live longer than their slow-moving counterpart. GPS satellites must account for time dilation, or their navigation would be off by miles. Every day, technology that depends on relativistic corrections proves that time really does pass differently depending on your motion and gravitational environment. I remember the first time I saw the experimental confirmation of time dilation. It was through the work of Hafele and Keating in 1971, decades after my initial calculations. They flew atomic clocks around the world on commercial airliners and measured the time differences when compared to reference clocks on the ground. The results matched my predictions with terrifying precision. The universe had confirmed that time really is relative, that my nightmarish thought experiment reflected actual physical reality. The atomic clocks flying eastward lost time relative to the ground-based clocks, while those flying westward gained time. The differences were tiny, mere nanoseconds, but they were exactly what my equations predicted. In that moment, watching the data, I felt a mixture of triumph and sorrow. My theory was correct, but so were its heartbreaking implications. Even more disturbing was the realization that this effect occurs constantly around us, though usually at scales too small to notice. Every time you walk up a staircase, you experience time slightly differently than someone on the ground floor due to gravitational time dilation. Every time you drive in a car, you age imperceptibly differently than someone standing still due to velocity time dilation. The effect is minuscule at everyday speeds, but it's there, constantly, reminding us that time is not the universal constant we once believed it to be. The most chilling realization came later. This effect scales with velocity and journey duration. The faster Fritz travels, the greater the time difference. A journey at 99.9% light speed would create an even more dramatic age. At 99% light speed, Fritz could travel for what seems like months to him, while centuries pass on Earth. He could return to find human civilization completely transformed, his entire species evolved beyond recognition. I've calculated these extreme scenarios in my private notebook, scenarios I've never shared publicly because they seem too cruel to contemplate. A traveler at 99.999 mind spent light speed could experience a journey lasting 1 year, while 224 years pass on Earth. Every friend, every family member, every person they ever knew would be long dead. They would return not just to a different time, but to a different world entirely. I remember walking through the streets of Bern the morning after I derived these equations, looking at couples holding hands, parents with children, friends sharing conversation. I wanted to warn them, love someone while you can. In the same time frame, Because the universe has ways of separating people that transcend death. Death, at least, is final. Time dilation creates a form of living loss that's almost worse. The paradox isn't really about the mathematics. Those are clear and consistent. The paradox is about the human heart trying to comprehend a universe where forever doesn't mean what we thought it meant. Years later, as I developed general relativity, I discovered even more disturbing implications. Strong gravitational fields also cause time dilation. Someone living in a deep gravitational well ages more slowly relative to someone further away. This means that even without traveling at high speeds, people can experience time differently. Imagine a scenario where Fritz doesn't travel to the stars, but instead lives on a planet orbiting a massive object like a black hole. The intense gravitational field would slow his personal time frame relative to Hans on Earth. Fritz could live what feels like a normal lifetime while millennia pass on Earth. When he finally leaves that gravitational environment, he would emerge into a universe where human civilization has risen and fallen multiple times. The cruelest part is the irreversibility. There's no going back, no way to synchronize timelines once they've diverged. Fritz can never reclaim those lost years with Han. He can never experience the life events he missed. The time dilation effect is permanent, absolute, final. This is why I sometimes regret opening this particular door of understanding. Before relativity, time was universal, absolute, democratic. Everyone experienced it the same way. Now we know that time is personal, relative, and potentially tragic. But perhaps there's beauty in this tragedy. Perhaps the knowledge that time is precious and finite makes our shared moments more meaningful. When I realized that the universe allows for different personal timelines, I also realized how extraordinary it is when two people's timelines align, even temporarily. Every conversation, every shared meal, every moment of connection between people happens within a narrow window of synchronized time. We take this for granted, but it's actually miraculous. In a universe where time can diverge so dramatically, the fact that we can share experiences at all is a profound gift. The twin paradox forces us to confront the nature of time itself. We think of time as flowing like a river, carrying us all downstream together. But time is more like an ocean, with currents that can separate us, depths that can trap us, and tides that can strand us on distant shores. Yet even knowing all this, would I choose ignorance over knowledge? Would I take back the equations that reveal time's true nature? No, because understanding the universe's deepest truths, even when they break our hearts, is what makes us human. The twin paradox will always remain one of the most emotionally challenging consequences of modern physics. It shows us that the price of reaching the stars might be losing everyone we love, but it also shows us something else. That love, connection, and shared experience are precious precisely because they exist within the narrow constraints of synchronized time. Every moment you spend with someone you care about is a victory over the universe's tendency toward temporal separation. Every shared experience is a defiance of relativity's lonely implications. In a cosmos where time can divide us so completely, choosing to be present with each other becomes an act of cosmic rebellion. But let me tell you something that haunts me even more than the mathematics. I've received letters from scientists, from dreamers, from young people who understand the implications of what I've discovered. They write to me asking, "Professor Einstein, if I could travel fast enough, could I meet my future self? Could I escape the pain of loss by jumping forward in time?" The answer breaks my heart every time I write it back. You could travel forward in time, but you can never travel backward. You can never undo the temporal separation. You can never return to share those lost moments with the people you left behind. I've calculated scenarios that make the twin paradox seem merciful by comparison. Imagine a woman whose husband volunteers for a relativistic mission to save humanity. He travels to a distant star system at 99.9% light speed to establish a colony. From his perspective, the journey takes perhaps 5 years. From hers, it takes 50. He grows old waiting. He has children, watches them grow up, becomes a grandmother, all while holding on to the memory of a young man who promised to return. When he finally comes back, still young, still calling her name with the same voice she remembers, she is dying. Her last words to him are about their children he never met, their grandchildren who look older than he does, a lifetime of love that aged while his heart remained frozen in the amber of near-light speed. The universe doesn't just allow this scenario, the universe guarantees it mathematically, inevitably, without exception. And here's what makes it worse. The travelers know this before they leave. They understand the price of their journey. Yet some still choose to go. Why? Because sometimes the mission matters more than personal happiness. Sometimes saving humanity requires sacrificing everything that makes you human. This is the true horror of the twin paradox. It's not just about physics. It's about the choices we make when we understand the full consequences of time dilation. It's about love measured not in moments, but in the synchronization of personal timelines. It's about the realization that "I'll wait for you" becomes the most tragic promise in a relativistic universe. I've spent sleepless nights wondering if my equations have created a new form of moral dilemma. If humanity develops the technology for near-light travel, who has the right to ask someone to sacrifice their synchronized lifetime with loved ones? Who has the authority to break families apart to cross time itself? The mathematics are clear. Time dilation is real, measurable, and inescapable. But the human response to this knowledge is up to us. We can despair at time's relativity, but we can celebrate the miracle of our synchronized moments while they last. The twin paradox teaches us that in a universe where time can be bent, stretched, and divided, the greatest luxury isn't space travel or advanced technology. The greatest luxury is sharing the same moment, the same heart, the same tick of the cosmic clock with someone you love. Every synchronized second is a gift that the universe has no obligation to preserve. But here's what terrifies me most about my discovery. As I grew older, I realized we're all experiencing a version of the twin paradox every day. Every time someone we love travels to different altitudes or moves at different speeds, we experience infinitesimally small time dilation. We age at slightly different rates, even when trying to stay synchronized. This realization came to me one evening walking with my wife through Zurich. Even in that romantic moment, the universe was pulling us apart at the quantum level, aging us at imperceptibly different rates due to microscopic variations in gravitational fields. The twin paradox isn't just about dramatic space travel. It's about fundamental loneliness of consciousness in a relativistic universe. We are temporal islands experiencing personal flows of time, occasionally synchronized but never perfectly matched. Yet paradoxically, this knowledge makes our shared moments even more precious. When I derived the equations for general relativity, when I finally understood how mass and energy curve space-time itself, I realized that every moment of true connection between human beings is a miracle. Against all the forces that try to separate us temporally, we managed to find these windows of synchronization where our personal timelines briefly align. Consider this. Right now, as you hear these words, we're sharing a moment across time. My thoughts preserved in these equations are synchronizing with your consciousness decades after I conceived. This is time travel, not the dramatic relativistic kind that separates twins, but the gentle kind that connects minds across generations. The mathematics that describe the twin paradox also describes something beautiful. How ideas transcend temporal barriers. My equations will outlive my body. They will continue describing reality long after everyone who knew me has died. Understanding relativity achieves a kind of immortality that transcends biological limitation. When future generations develop near-light travel technology, when they face the real moral dilemmas of the twin paradox, they will use the same equations I derived in my apartment in Bern. Across centuries, my thoughts will inform their decisions. Einstein and humanity, synchronized not by sharing the same moment, but by sharing the same understanding. The twin who travels carries more than consciousness on his journey. He carries accumulated human knowledge, mathematical insights that made his journey possible, our species' hopes and dreams. He doesn't travel alone. He carries all of us, compressed into the equations that guide his ship. When he returns, aged differently than those he left behind, he brings brings confirmation of our theories about reality. He becomes living proof that the universe operates according to mathematical principles we discover through thought and observation. This is the hidden redemption within the twin paradox. Yes, it separates us temporarily. Yes, it creates heartbreaking scenarios of asymmetrical aging, but it reveals that consciousness and understanding can transcend temporal barriers. Love, expressed through mathematical truth, can bridge any gap physics creates. The twins are separated by time but united by equations that predicted their separation. They age at different rates, but share the same universal constant, the same laws of physics, the same mathematical harmony governing all space-time. In the deeper sense, they remain connected by forces more fundamental than temporal synchronization. This is what I want people to understand about the twin paradox. It's not just a cruel consequence of relativity. It's a profound demonstration of how knowledge can create connections that transcend even the most fundamental barriers physics can erect. Time may separate, but truth unites us across any distance, any duration, any gap the universe creates.